And then let's look at question D, which is on a different distribution. So now notice the difference. In fact, here they are even giving you that it's a Poisson distribution. Okay? But how do you know, in case they don't state, how do you know that this is a Poisson? So for the questions on the Poisson distribution, you'll only be given one thing, which is the mean. Okay? You'll only be given one thing, which is the mean. So just the mean, it's enough for you to do all calculations that are involving a Poisson distribution. Okay? Because why? In their formula, only the mean is important. The other things, they are just basics. So you can say they're saying the number of industrial injuries per working week in a particular medical factory is known to follow a Poisson distribution with mean, mu. Okay? So they're saying given, so understand the question, they're saying given that the probability that no accident will happen, okay, is 0.6065, one decimal place, find the value of the mean. So always in a Poisson distribution, you'll only be given the mean, or you'll be asked about the mean. Okay. So there are two important formulas that you have to know under the Poisson. But anyway, I think the other one, I won't state it here. But let me state the one for the probability. Okay. So under the Poisson distribution, the probability, okay, of X, or some people say the probability of X, big X, being equal to a smaller x, it's just the same. You can write like this or you can write like this, it's the same. So the probability of x under the Poisson distribution is equals to E, okay, to the power, the mean, and then you multiply the mean, okay, to the power x. This x will be the random variable that will be changed. So if it's a probability of 1 where there's x, you put 1. Probability of 0 where there's x, you put 2. Okay, and then you divide all these by x factorial like this. So this is a very simple formula that you must know for the Poisson. Okay, so remember here you've been given now that the probability of 0 is 0.6065. So you see that just knowing the value of x and probability, we'll be able to come up with this mu here. So this mu here is also here. Okay, so let's find the mu now. So we just have to replace into the formula here. So we're going to say the probability of 0 is 0.6065, which is equals to, okay, e to the power mean, but the mean, we don't know it. Okay, so I'm going to say e to the power mean, which is represented by mu, then multiplied by the mean that I do not know to the power x. In this case, my x is 0 divided by x factorial. My x is what? 0 factorial. So you see that 0 factorial is 1, right? So I'm going to have 0.6065 is equals to e to the power minus mean. Because this one here is going to give us 0, because anything to the power 0 is just 1. Okay. All right, so this is what we have. And then from here, you just have to introduce log on both sides. Okay, just have to introduce log on both sides so that you can drop this guy. So you're going to say ln, even here you're going to say ln. So if I introduce a log, it means this one here will drop. So I'm going to have ln 0.6065 is equals to minus mu ln e. And we know that this ln e here is always 1. Why? Because those properties of logs that we learned in first semester, they did. Because ln is just a log to base e. So you have log e, e. So if these are the same, we said it's always 1. So this one here is 1. So we have minus mu being equals to ln 0.6065. Okay, so you just get your calculator and punch that value. So you can even say your mu will be equals to the minus of this. So minus ln 0.065. Okay, let's punch into our calculator to find this. So minus, and then punch this into your calculator. So if I punch this into my calculator, I'm getting a minus 0.500. 5055. Okay, so meaning our mu will just be positive of this. So let's put to 3 decimal places. We're going to have 0.500 as our mean. Okay, so this is our mean, our mu. Okay, so any questions there? How are we able to find that one?
No questions.
Okay. All right, let's look at the other question.